Math 2, Unit 7 review. We just took the Unit 7 test earlier this month. As a matter of fact, we took it last week. And I tried to summarize Unit 7 down into 3 basic parts. Do you know your Pythagorean Theorem? Was the first part. Do you know your special right triangles and how to use it? Was the second part. And the third part was, did you know SOHCAHTOA? Did you know how to do sine, cosine, and tangent? When to use it? When to use the inverse? When to not use the inverse? And so on with Unit 7. And if we did that, the only other thing we added at the end was word problems that had words like angle of elevation and angle of depression. If we remember, the angle of elevation is from horizontal going upwards. From horizontal upwards, that's an angle of elevation. An angle of depression is from level downward. That would be the angle of depression. Those are things that we learned so that we could use SOHCAHTOA in our problems. The first thing that we should talk about is the Pythagorean Theorem. You should know what it is. It's a squared plus b squared equals c squared. And you can use this when you know two sides of a right triangle and you're trying to find the third side. You have to know two sides. It could be one leg and the hypotenuse or both legs and you're finding the hypotenuse. The hard part was you need to know that C was the hypotenuse or the longest side. The other thing that we did with Pythagorean Theorem besides solving was that we could use it to figure out whether the triangle was a right triangle or whether it was not a right triangle. If a squared plus b squared was equal to c squared, then it had to be a right triangle. If a squared plus b squared was less than c squared or greater than, then it was not a right triangle. It could have been obtuse or acute. And then, of course, with these radicals, and when you're dealing with Pythagorean theorem, sometimes you're going to have to deal with radicals, and I recommend using the calculators that do radical form. So if you do not have a calculator that has square roots and radical form, then I would recommend using or borrowing one that does. I know that I have those in my class. Special right triangles sort of evolved a little bit as we were doing the problems. This will be given to you as you take your final. It is on the formula sheet. But what you needed to know is what is across from every single angle. The way we solved these, there was very little work. It was just understanding the pattern. Across from the 45 was S, across from the other 45 is S, and across from the 90 is S root 2. Now if you learn that, then if you know that S was 7, then the other side had to be 7, and then the hypotenuse would have to be 7 root 2. That's how it worked. You learned that if you knew that on a 30, 60, 90, if this was 18, well then S would have to be 9. 2 times 9 is 18, and then that would make that 9. That would make that 9 root 3. It was just knowing the pattern. What's across from the 30 is S, what's across from the 90 is 2S, and what's across from the 60 is S root 3. So, Section 1, Pythagorean Theorem. Section 2, Special Right Triangles. Section 3 was on SOHCAHTOA and whether you knew how to use sine, cosine, and tangent. I tried to break this down into 2 steps. First was, what's your angle? Label it O, H, and A. O stood for the opposite. H stood for your hypotenuse. A stood for your adjacent. So, what was your angle? O, H, and A. And then you would choose whether you were going to use sine, cosine, or tangent using the acronym SOHCAHTOA. S stood for sine, O and H stood for opposite over hypotenuse. C stood for cosine, A and H stood for adjacent over hypotenuse. T stood for TOA, T stood for tangent, O and A stood for opposite over adjacent. So, using those two things, we could figure out what a ratio was of tangent. We could actually figure out or use an angle to find a missing side. And then even in 7.4, we could figure out what angles were. If we didn't know what an angle was, we could use theta to represent our unknown angle, and then we could get rid of sine and cosine and tangent by using its inverse. These are usually above your, if you press second sine, second cosine, second tangent, or shift, you can get to those buttons on your calculators. And that's really Unit 7. If you need anything more, if you need more detail of how to do something in 7.1, 7.2, 7.3, 7.4, 7.5, those videos are on my website as well. And we'll end your notes right there.